Hello everyone. So start with today's question. So today's question is, suppose the system has 12 magnetic tape drives and at time t0 three processes are allocated tape drives out of their needs as given below. So we have given three processes and these three processes have maximum needs given in the first column and the current needs given in the second column. And after that we have to find the safe safe sequence, that is ठीक है, so that the deadlock will be avoided. So we have to find in this question the safe sequence in which the deadlock will not be occurred. So firstly we should know what is deadlock. So deadlock is a condition where a program cannot access a resource it needs to continue. It means that understand the concept of deadlock with this example. So here in this example we have given the two processes p1 and p2 and we have given two resources r1 and r2, and in this example the process p1 requested for the resource r2, but this resource r2 is allocated to process p2. Okay, and the process p2 requested the resource r1, but this r1 resource is already allocated to the process p1. So by doing this form this cycle and the deadlock will be occurred here. So back to the question. So in this question we have to find the safe sequence. So this problem will be solved with the help of deadlock avoidance algorithm. So we already know various algorithms are used for the deadlock avoidance, but the famous algorithm for deadlock avoidance will be Banker's algorithm. So this question will be solved with the help of Banker's algorithm of deadlock avoidance. This is the Banker's algorithm. Okay, so in this algorithm firstly we have to create the table of 5 columns. So the table is created with the 5 columns, the columns named as processes, maximum need, current allocation, current available, remaining needs. Okay, these are 5 columns, and the first column the processes. Under the processes in the first column we have mentioned the three processes as a p1 p0 p1 and p2. These are processes given the question, and the processes are p0 p1 and p2 given in the already in the question. So next column is the maximum need. So the maximum need already given in the question, that is the process p0 the maximum needs are 10. For the process p1 the maximum needs are 4, and for the process p2 the maximum need are 9. Okay, so write these maximum needs in the second column. Now the next column is the current allocation. So the current allocation already given in the question, there is the current needs are the current allocation. So the process p0 the current allocation is 5 magnetic tapes. So write 5 in the third column in front of the p0 process, and the second is the process p1, it needs 2, the current allocation is 2, and the process p2 the current allocation will be 2. So write this current allocation in the third column like as. Okay, next is the remaining need. Okay, we have to find the remaining need, and this remaining need will be find out with the help of the given formula. This is the formula for the remaining need. So remaining need is equal to maximum need minus current allocation. So maximum need for the processes given in the second column, that is the process p0 the maximum need is 10. Okay, and the current allocation is given in the third column. So the process p0 the current allocation is 5. Okay, so 10 minus 5 is equal to 5. Okay, so second is the process p1. So the maximum need for the process p1 is given is 4, and the current allocation for the process P1 is 2. Okay, 4 minus 2 is equal to 2. And the third row is process P2. So process P2, the maximum need is 9 and the current allocation is 2. So 9 minus 2 is equal to 7. Okay, like this. Now next we have to find the current available. So the formula for the current available is given as this one, total available minus total current allocation. So here in this case the total available is the maximum available magnetic tapes given the question. So in the question the maximum given magnetic tapes are 12. Okay, this is the total available and minus total current allocation. So total current allocation is the sum up of these numbers. Okay, so total current allocation is equal to 5 plus 2 plus 2, that is the 9. Okay, so the current available is equal to total available means 12 minus total current allocation means 9. So 12 minus 9 is equal to 3. Okay, like this. So now we have the current available magnetic tapes are 3, this one, and the remaining need for the process is given this column, that is process P0 need 5 magnetic tapes, process P1 need 2 magnetic tapes, and process P2 need 7. Okay, and currently we have available only 3 magnetic tapes. So when we are checking for the remaining need for the processes, we got that the process P1, this one, the process P1 required 2 magnetic tapes. Now the process P1 remaining needs are 2 and we have available is 3. So we have to check all the processes P0, P1 and P2, that which process it satisfies its needs. So all the 3 processes, the P0 require 5 resources, P1 require 2 resources and P2 requires 7. So according to this it satisfy the process P1 need, because P1 require only 2 resources and the other processes require 5 and 7. So 5 and 7 are greater than 3, that is the current available. The 5 and 7 are greater than 3, so it is satisfy the P1, that is the process P1 need. So we allocated the 3 available resources to the process P1, and after finishing its work the process P1 releases its all resources. So in the earlier we allocated the current allocation for the process P1 is 2 and we allocated the 3 resources to the P1. So so process P1 releases its all resources. So the resources for the P1 are 3 plus 2, it releases the 5 resources and we have available resources are 5, that is the 3 plus 2. Okay, so now we have the available resources are available is 5 and P1 already finished its work. So it's finished its execution. So now we have available processes are P0 and P2 and we have current available resources are 5. Now we have to check these processes that are P0 and P2 for the remaining needs, and the P0 need 5 resources and P2 needs 7 and we have available 5 resources. So it satisfies the P0 remaining need, because P2 requires 7 resources and we have available 5, that is a 5 is less than 7. So it satisfies the P0 remaining needs. So we allocate these 5 resources to the P0 and after finishing its work, that is the P0, it releases all its resources that we already allocate to the process P1. जो हमने पहले भी P0 को allocate किए थे resources, वो resources और जो अभी हमने P0 को allocate किए resources वो सारे ही P0 रिलीज कर देगा. ठीक है, so we have now available resources are 5 जो हमने पहले allocate किए थे, जो हमने अभी allocate किए वो ये हैं. So the available resources are 5 plus 5 is equal to 10. Okay, and P0 already finished it works, so we add this P0 after P1, this one. Okay, now we have available resources are, or current available resources are 10, and the process we already left it is to P2. So P2 remaining needs is 7, and we have available resources are 10, so it can satisfy the P2 remaining need. So we allocated these resources to the P2, and after finishing its work, the remaining or the available resources are 10 plus 2 is equal to 12. Okay, so sequence is P1, P0 and P2, and after execution the resources हमारे पास फिर से क्या बच के 12. Okay, so in the question already given the resources are 12, and we already done the working of the 12 with the 12 magnetic tape drives, and the safe sequences P1, P0 and P2. So the according to the question, the option is B option, the second option, and the second option, the safe sequence is P1, P0 and P2, and by executing these processes in this manner, the deadlock will not be occurred. So this is the solution, this is the answer of the given question. So this is all about the today question. So please subscribe, share and like the video. Thank you.